Hello there, welcome to this video. And for this video, I will explain about graph of polynomial function. Before we start our lesson, let us first familiarize some of the basic in graphing of polynomial function. So one of the basic here is the behavior of the graph. When we see the behavior of the graph, it determines to the end behavior of the arrows of our graphs. So I have here the type 4. So for the type 1, when we say type 1, the degree is odd. When we say odd, it is numbers written in 2n plus 1. The degree is odd, leading coefficient is positive. Example for that is ax cubed plus bx squared plus cx plus d is equal to 0. So those are polynomial functions with odd degree and the leading coefficient is positive. So the behavior for that is graph falls to the left and rises to the right. So graph falls to the left, so it looks like this one, and rises to the right. The other arrow rises to the right, so more likely the form is like this one. Okay, so for we have the type 2. Type 2 is the degree is odd also, and the leading coefficient is negative. So we have the example negative ax cubed plus bx squared plus cx plus d is equal to 0. So for the type 2, the behavior for that graph is it falls to the right and rises to the left. So falls to the right and rises to the left. So more likely the graph looks like this. Okay. Next, for the type 3, degree is even, leading coefficient is positive. So the example for that is ax squared plus bx plus c is equal to 0. So the behavior for type 3, graph rises to the left and to the right. So the behavior rises to the left for type 3 and also rises to the right. So more likely the graph looks like this. Okay, the arrows rises to the left and to the right. And lastly, for the type 4, degree is even, leading coefficient is negative. The example for that is negative ax squared plus bx plus c is equal to 0. So for this type, the behavior of this graph is falls to the left and to the right. So falls to the left and to the right. So more likely looks like this. Okay, so those are the types in graphing of polynomial function. These are the behaviors: type 1, type 2, type 3, and type 4. Okay, so let's consider the example. I have an example number 1. The polynomial of x is equal to x cubed plus 3x squared minus x minus 3. Okay, so I have here the steps in graphing of polynomials. So first we have to determine the end behavior. So it is either type 1, type 2, or type 3 or type 4. The next we can find the x and y intercept of the graph or the function. Then for letter C, we have table of values. We will construct later table of values. And for letter D, the turning points. The turning points of the graph is determined by n minus 1, where n is the degree or the highest degree of the polynomial function. And for the lastly, we will plot the points. Okay, so let's go to letter A. determine the end behavior. So let us look the given. So the given is x cubed plus 3x squared minus x minus 3. So if you look at the highest exponent, that is x cubed, that is 3. So 3 is an odd number. So it is either type 1 or type 2. But look at the leading coefficient, it is positive. Therefore, it is type 1. Degree is odd, leading coefficient is positive. So it is type 1. So more likely, the behavior of the graph falls to the left and rises to the right. Okay. So this is type 1. The answer for this is type 1. Okay, type 1. The next, for letter B, find the x-intercept and also the y-intercept. So to find first, we'll find first the x-intercept. To find the x-intercept, we will let p of x is equal to 0. Okay, so the given will become x cubed minus 3x squared minus x minus 3 is equal to 0. So what we'll do is to find the value of x by the method of factoring. So we'll factor this one. We'll look for the first and second term, x cubed minus 3x squared. I can group this one. So these first two terms. So I can factor out here the x squared. So become x minus 3. For the third and fourth term, I can also factor out the negative sign, so it becomes x plus 3. Should be next x plus 3. Okay. Is equal to 0. That should be positive. This positive. Okay, now we can factor out the quantity of x plus 3 from the first term and also the second term. So this becomes x plus 3 x squared minus 1. Okay, so from here we can now find the value of our x. So for this one, x plus 3 is equal to 0, and the other one is x squared minus 1 is equal to 0. So it follows that the value of x is equal to negative 3, and for this one, the value of x is equal to positive and negative 1. Okay, that is for the x-intercept. And for the y-intercept, we will just simply let x is equal to 0. Okay, to find the y-intercept, we will let x is equal to 0. So from the given equation, x cubed plus 3x squared minus x minus 3 will become p of x is equal to 0 cubed plus 3 0x squared 0 squared minus 0 minus 3. So therefore p of x is equal to negative 3, or simply y is equal to negative 3. P of x or y is they are the same. Okay, so that is our x-intercepts and that is our y-intercept. So after this one, we need some more values for x so that we can better visualize our graph. So I have here letter C. You can construct table of values like this way. So I have here x and also y. So if x is 0, we know that it is negative 3. x is 1, we can simply substitute the value of x is equal to 1 to the polynomial function. So when x is 1, we have p sub p of 1 is equal to 1 cube plus 3 times 1 squared minus 1 minus 3. Okay, so this is equal to 1 plus 3 minus 1 minus 3. So we can cancel this one, cancel. So it follows that p of 1 is equal to 0. So p of 1 is equal to 0 here. The next, when x is equal to negative 1, it also 0 from the given here. Then when x is equal to negative 3, that's equal to still 0. How about if x is equal to positive 3? So just simply substitute the given. So p of 3 is equal to 3 cube plus 3 cube squared, 3 times 3 squared minus 3 minus 3. Okay, so we can now simplify this one. So 3 to the power of 3, that is equal to 27. 3 times 3 squared, that is also 27. Then minus 3, you can do minus 6. Okay, 54 minus 6, that is equal to 48. So when x is equal to 3, your y value is equal to 48. Okay, so we will use this value in the table of values in plotting of points for our graph later. So we are done with letter C. So next we have our letter D, the number of turning points. When we see the number of turning points, it is the curve like this, this one. So for this one, I have 2 turning points here. So one, this one, and this another one. So we have 2 turning points. For this one, we have also 1 and 2. And for this graph, I have only 1 turning point, and also for this graph. Okay, how to determine the turning points? We can have not just only 1 turning point, not just only 2 turning points, but we can also have 3 turning points, 4 turning points. Depends on the highest degree of our polynomial function. So for this one, for our given, we have the given x cubed plus 3x squared minus x plus minus 3. The number of turning points is determined by n minus 1, where n is our highest degree. So for the highest degree in our polynomial given in the example, that is equal to 3. So 3 minus 1 is equal to 2. So it follows that we have 2 turning points in our graph. So we can see that later on. Okay, next is plot the points. So we will now plot the points. So we will use this information in C from table of values to plot our points. Okay, for this one. Okay, so when x is 0, so the 0 is here in the origin. When x is 0, your y is equal to negative 3. So from 0 here, we'll start counting to negative 3. So down, 1, 2, 3. So put this one. The red one will indicate our the intercepts or the points. Next, when x is 1, your y is 0. So when x is positive 1 here, your y is 0. So when x is 1, 0, you cannot move because y is 0. So this one. Next, when x is equal to negative 1, so when x is equal to negative 1, your y is also equal to 0. So will not move because your y is 0. So we'll put our point here. Next, when x is equal to negative 3, your y is 0. So you count negative 3, 1, 2, 3, negative 1, negative 2, negative 3. Then your y is 0. So will not move. So here. So we have 3 x-intercepts, 1, 2, and 3 as our desired result. Next, when x is equal to positive 3. So when x is equal to positive 3, your y is equal to positive 48. So 1, 2, 3. Then your y is we will count up 48 up to 48. So 1, 2, 3, 4, 5, 6, 7. You can estimate this one as here. Point is here because 48 is so high. So we can estimate there. Okay. So we are done in plotting the points. Remember, this is a type 1 graph. The end behavior, meaning the end behavior for the type 1 falls to the left and rises to the right. So falls to the left. So we will falls to the left here and rises to the right here. So now, next, before we connect this one, we should identify first our turning points, the number of turning points. The number of turning points, as we got earlier, it is 2. So meaning we have 2 curves, 1 and 2. Okay, so we'll connect the points here. So we can connect this one. We have 2 turning points, remember, this is 1. The next will go down, then up. So this is the second turning point. Okay, like this one. The graph may not look accurate, but actually they are the same. If we'll graph this one in a calculator. So the graph for the number 1 example is like this one. Okay, falls to the left and rises to the right. Then we have 2 number of turning points. If you observe also, we have the y-intercept negative 3. We solved it earlier. Y is equal to negative 3. So we have here y is equal to negative 3. So intercept, when we say intercept, it is a point where the graph is passing through in the x and y axis. So for the y axis, it is equal to negative 3, and for the x axis, we have positive 1, negative 1, and negative 3. So that is example for number 1. So now let's consider another example. We have example number 2. P of x is equal to x to the power 4 minus 9x squared. So we'll solve this one. So the same step as we did earlier in number 1, we'll determine first the end behavior. So this is the end behavior. The end behavior can be determined by just looking at the given function. So this is x to the power 4 minus 9x squared. So the degree is even and the leading coefficient is positive. So that is type 3. Okay, as a review, this one, the degree is even and the leading coefficient is positive. So the behavior of the graph, it both rises to the left and to the right. So we can expect that the arrows is rising to the left and to the right. Okay, so next, this is type 3. For letter B, we'll find the x and y intercept. X-intercept. Okay, for the x-intercept, again, we will let p of x is equal to 0. So this one becomes x to the power of 4 minus 9x squared is equal to 0. Then we will simply solve for the value of x. So from here, we can see that x squared is common to the first and second terms. So we can factor out x squared. So it becomes x squared minus 9 is equal to 0. So notice also that x squared minus 9 is, it follows the property a squared minus b squared. So it can be written as a plus b, a minus b. Okay, so we'll follow that pattern. So x squared minus 9 can be written as x squared minus 9 is equal to x plus the square root of 9 is 3. So put here 3. Then next is x minus the square root of 9 is also 3. So we can write this one as x squared x plus 3 x minus 3 is equal to 0. Okay, so it follows that the value of x is equal to 0. The second one, we have x is equal to negative 3, and for the third one we have x is equal to positive 3. So that is for x-intercept. Now we'll find the y-intercept. So again, to find the y-intercept, we will let x is equal to 0. So this time our x will become 0. So p of x is equal to x squared minus 9x squared. So p of x or y, so this is 0 fourth minus 9 0 squared. So simply y is equal to 0. So that is our y-intercept. Next, we will construct table of values. Okay, so for letter C, the table of values we have like this way. Okay, so we can write this one as this one. So x and y, we'll copy first our x-intercept. Our x-intercepts are 0, negative 3, and 3. So I can have any arbitrary numbers here, 1, negative 1, or 2. Okay, so when x is 0, we know that y is equal to 0. When x is negative 3, your y is also 0. When x is positive 3, we know that y is also 0. Okay, next, we can also include our y-intercept here. The red one is our y-intercept. It follows that if y is 0, x is also 0. Okay, so next, when x is positive 1, it's the value of your y. So y will solve this one, x squared minus 9x squared. So we can say that when x is equal to 1, minus 9, so this 1 to the power of 4 is still 1. Then 1 squared is also 1. So 1 minus 9 is equal to negative 8. Okay, the next, when x is equal to negative 1, connect this one, the red one. So when y is equal to negative 1, so 9 negative 1 squared. So if the exponent is even, the base will become always positive. So this is 1. If you multiply 1 4 times, it is also 1, also 9. So this is also positive because the exponent is even, so 1. So also the same answer with negative 8. Okay, next, when x is equal to positive 2, this at x is equal to negative 1, at x is equal to positive 1, then at x is equal to positive 2. So we know that 2 4 to the power of 4 minus 9 2 squared. So 2 to the power of 4, that is 2 times 2, 4 times 2, 8 times 2, 16. We have to multiply 2 4 times, 16. The next we have 2 squared, that is equal to 4. 2 times 2 is 4. Then 16 36. 16 minus 36, that is equal to 20. So when x is 2, ry is equal to 20. So now we have now the table of our values. Next is for the number of turning points. So number of turning points for letter B. So remember, it can be determined by the formula n minus 1, where n is the highest degree of the polynomial function. So this time our n here for the given, we have 4 because this is the highest degree. So it follows that 4 minus 1 is equal to 3. So meaning the number of turning points for number 2 is 3. Okay, take note this one, we have the number of turning points is equal to 3. So next we have to plot for letter E, plot the points. So plot the points. We'll be using the table of values this time. So I have here when x is 0, your y is also 0, this one. When x is negative 3, your y is also 0. So when x is negative 3, negative 1, negative 2, negative 3, so your y is 0, you put the point here. Next, when x is positive 3, 1, 2, 3, your y is 0. Next, when x is positive 1, your y is negative 8. So from here 1, your x is 1, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8. So the point is here. The next, when x is negative 1, is also negative 8, your y. When x is 2, your y is positive 20. Let's say here 20 is here. So now we can now connect the points. Determine first the end behavior. So this is, remember, this is type 3. Okay, type 3. So the end behavior means it rises to the left and to the right. So it looks like this. This one looks like this. So the arrow would be up here. Okay, so we're almost done with this. So let's say the positive 20 here, it's so high, it's 20. So we can connect this one. Remember, we have 3 turning points, so we'll make 3 curves. So connect the points, 1, then we'll go up. So we have now the first turning point, and go down, second turning point, The next is go up. So we have 3 turning points. Okay, so it looks like this. The graph looks like this. Should not be 20 here. Okay, so that is the steps in graphing of polynomial function.